Hi, we're going to be doing lesson 5 in multiplication, and you're going to be multiplying with mostly 2s, 5s, and 10s. And then at the end, I'll give you a challenge working with 0s and 1s. There are many important vocabulary words associated with multiplication, and you probably have heard some of them in class this week and on your hybrid lessons last week. Multiplication is an operation used to find the total number of items in a given number of equal size sets or groups. Now, I have the word operation in italics here, and that is because the operations, when we're talking about operations in mathematics, we mean multiplication, division, addition, and subtraction. In this case, we're focusing on multiplication. When you multiply, that means to repeatedly add the same number a certain number of times, and it's used to find the total number of items in equal size sets or groups. And that is really important. You have to have the same number of items in that group, or the repeated addition has to be the same. Like, for example, if you had 3 groups of 5, you would have to have 5 plus 5 plus 5 for the repeated addition. It would not be multiplication if you had 5 plus 5 plus 4. You have to have equal size sets and groups. In that case, you would have a little bit of multiplication and then addition at the end. So that would be a multi-step problem. Let me move this over. And then other common words, you're going to hear me say a factor times a factor is a product oftentimes. So it is the number that is multiplied is a factor. And the product, see, my screen is in the way. The product is simply an answer to a multiplication problem. The product is the result of multiplication. It is the answer. Just like when you're dealing with addition, the answer is called a sum. When you're dealing with subtraction, the answer is the difference. With multiplication, it is the product. And when you get into division, you're going to find that the answer is called a quotient. More vocabulary continued. An array. I know that you know that they are an arrangement of rows and columns. It's a set of objects arranged in equal rows and equal columns. The rows going horizontally, they stand for the first factor in a multiplication problem, and the columns, the vertical, stand for the second factor. But if you really look at each row and you counted what was in each row, that will tell you how many columns there are. A model can be many things, but more than likely it's going to be a picture that is given to you or a picture that you draw that represents groups and an equal number of objects in a group. Multiplication models include skip counting, equal groups, arrays, and equations. The first factor, because there's a first factor and a second factor, so a factor times a factor. That number is multiplied representing the number of groups. Okay, there it is. And you can ask yourself, how many groups are there? And then the second factor is really hidden, and that is the number of items that are in a group. Okay, if you understand the concept of multiplication, because that is really the conceptual understanding of what those words mean, and then you develop a deep understanding of the process of multiplication, you'll be able to use strategies that you learn or use and create meaningful strategies to help you solve more problems that are more difficult. And the next lesson that we'll get to, you'll even have more tricks to keep inside your toolbox, because you'll learn how to break apart numbers when you're dealing with big multiplication problems to make it more manageable. That's one of my favorite strategies, I think, for kids. Okay, so in essence, when you're looking at multiplication, I think I want to make this smaller. Oh, that's as small as it can get. Sorry. I think you have the number of groups times items in a group, and that's going to give you your total, or a factor. The first factor times the second factor will give you your product or the total. If you're looking at an array, you have the rows times the column, and that will give you the total. And you're going to be working problems today in this lesson that have to do with bugs and legs on bugs. Okay, so you have a certain number of bugs, a certain number of legs on each bug, and that would give you the total number of legs there are altogether. Okay, so in your math notebook, not in your textbook, but in your regular math notebook, you can look at this problem. It's like a warm-up. You have 3 equal groups of 5 pencils, and they want to know how many pencils do you have in all. So when you're given a problem such as this, you know that you always, oh no, that popped in. I hope that you said to yourself, well, I have 3 groups and I have 5 pencils in each group. Therefore, this repeated addition would be 5 plus 5 plus 5. Or you can skip count by 5 3 times, and that looks like 5, 10, 15. This is where I thought I was going, but that's okay. So the other problem was really easy. And on the last slide, if we reversed it, if the question had different items and numbers, like we had 3 times 5, you could have 5 times 3 if you had 5 groups of something with 3 in each group. So that would be different, because that would be 3 plus 3 plus 3 plus 3 plus 3. That repeated addition would be different. Therefore, the picture would look different. The factors would be reversed, but the product would still be the same. So on to this slide. Let's try some out, and you can make sense of this problem. As always, when you're doing one of these problems, Mr. Reddy wants you to read the problem always 3 times, like it's a magic number. Okay, so Jenny draws 6 cartoon bugs. Each bug has 10 legs. How many legs did she draw? So as always, these are the things that you focus on. You read it 3 times and think about it. What is the problem about? What are you trying to find out? What information is important? And we're on page 105. Well, the information that is important, of course, the data includes the digits or the numbers. So if she draws 6 cartoon bugs and each bug has 10 legs, this word each is very important because it's telling you that you have equal size sets or groups. In this case, 10 legs. And then we need to know how many legs did she draw in all or all together, even though those words aren't there. So you have to ask yourself, are you able to identify the groups? And do you know how many are in each group? So think about that. Pause for a few minutes, and in your regular math notebook, see if you can come up with the multiplication equation that matches this information and then this question. So welcome back. And I hope you were able to identify the groups as being 6 cartoon bugs. So how many bugs do we have? We have 6 bugs, and each bug has 10 legs. So this would be 6 times 10. The repeated addition would be the second factor. So you could skip count by tens 6 times. And that's exactly what I did. I said 6 bugs, and I put 10 in the middle of each, and then I also put 5 legs on each side. So I have a total of 10 legs per bug. This one's a little squashed, but it's certainly there. So you can count by tens 6 times. Now, also on page 106, you have the look back section where you're making connections and explain your thinking. Explain how you found the number of legs Jenny drew for the 6 cartoon bugs. Well, I kind of just did that. I walked you through that process. So you could pause for a moment and then write it down. But I'm going to go ahead and click it because I've already worked through this. And this is what I did. I drew 6 groups of 10 legs each for each bug. So Jenny drew 60 legs in all. And then I used skip counting and I counted by tens 6 times. Hopefully that's what you came up with as well. Okay, still on page 106, now we're under the connected section, and this is make connections and explain your thinking. Number 2, look ahead. You can show and solve multiplication problems in different ways, such as using arrays or equal groups. One way to find products when multiplying with 2, 5, or 10 is to use skip counting. Suppose Jenny draws 8 cartoon bugs with 10 legs each. So here we have the number of groups. We should have 8, and I see 1, 2, 3, 4, 5, 6, 7, 8. And each bug still has this 10 legs each, so 5 on each side. So once again, you would be skip counting by 10. It says, show how you could use skip counting to find the number of legs Jenny drew. Well, you should skip count from 10, by tens 8 times. So 8 times 10 should give you, I see a basic fact here, 8 times 1, which will give you 8, and then you add that 0 back in, or you can skip count, and it looks like this. 10, 20, 30, 40, 50, 60, 70, 80. So if you write a multiplication fact to find the number of legs, you look at the number of bugs times the legs on each leg, so the total number of legs, and it should give you 8 times 10, and this is in the way, I don't want it there, equals 80. I have to stay away from that. Suppose you have 8 bugs with 8 legs each. What other method besides skip counting can you use to find the total number of legs? So I want you to stop the recording and work on number 3. I didn't put that page number in there, and I should have. I neglected to do that, and I don't see a page number for it either. Well, that's okay. Anyway, you can use a bunch of different strategies when you're solving this. And you could do, I can draw 8 equal groups of 8, or I can draw an array with 8 rows and 8 columns. Okay, it doesn't matter which way you do it. But one thing I wanted to point out, that when you have the same factors, that means that it's easier. You don't have to think as much because the repeated addition is the same. The number of groups is 8. The number in each group is 8. So the double facts are fairly easy to learn. I have some rhymes for you that I'll teach you in class to use, or your teachers will teach you in class. And I think you'll find it easier when you end up with problems like 3 times 3, 4 times 4, 5 times 5, et cetera, et cetera. And then my question is, do you think it's easier to draw a model or an array when the factors are the same? Why or why not? I kind of let the cat out of the bag and told you already, but you can think about that. Okay, this part you typically skip in class, but I thought it was important to do it just because multiplication really needs you to understand. You need to understand that conceptually, so the concept of multiplication. So the definition of multiplication, it's simply a multiplication equation. It's a factor times a factor equals a product. So you have a number times a number equals a number. Okay, the illustration I chose to put in there shows you that you have 1, 2, 3, 4, 5, 6. The first factor means the number of groups, and the second factor is the repeated addition, or how many are in each group. And you can see the picture matches this because it would be 5 plus 5 plus 5 plus 5 plus 5 plus 5. Repeated addition, if you skip count by fives, 5, 10, 15, 20, 25, 30, I'm going to get the same thing. The repeated addition takes longer, so multiplication is really a shortcut to addition. Another example, okay, if I have 5 times 2 is 10, I would have 5 groups with 2 in each group. I could skip count by 2's 5 times if I wanted to, because this picture would be 2 plus 2 plus 2 plus 2 plus 2. So I'd say 2, 4, 6, 8, 10. But that would match this picture, 5 groups of 2. But in my brain, if I were solving it, or if I was solving it, I could say, I'm going to skip count by 5 2 times, 5, 10, because it's much faster. So you get to decide what way you want to think. However, you have to be sure if they're asking you to draw a model of a particular multiplication problem, that your picture matches the problem that you're making, okay? 8 times 0 is 0. If you have any number times 0, okay, you're going to end up with 0, whether it's 100 times 0, 2 times 0, 50 times 0. And then the identity, this is called the identity, 9 times 1 equals 9. So any number times 1 will be itself. 100 times 1 is 100. Okay, 1,000,000 times 1 is 1,000,000. So this one shows 2 rows of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 1 row, 2 rows. So 2 rows of 10 is, I'm going to skip count by 10s 2 times. 10, 20. But if you wanted to, you could think, I'm going to skip count by 2's 10 times, and that would be 10 times 2 if you wanted to do that, but this picture would look totally different. And then non-examples of multiplication, that would mean that we'd have something that didn't have equal size sets or groups. So this is 6 plus 5 is 11. Those are unequal. And here's an array. These are not equal groups. This row has 3 in it. This row has 4 in it. And this row has 1 in it. So these would not be examples of multiplication. This is addition, and so is this, 3 plus 4 plus 1. So I thought it was important that we go over that today. Okay, I want you to pause the video and do independent practice. The independent practice pages, it's on page 108. You can see it in bold here. I want you to solve the problem and show your work. When you're doing it, ask yourself, what is the problem about? And also, what is the question that you're trying to answer? And what information is important? So here's what the problem is about. Here's the problem, actually. Julio made 7 cookies. Each cookie has 5 chocolate chips. How many chocolate chips did he use? So when you pause, again, reread the problem and think about that. What information is important? What will your picture look like? Okay, or will you make an array to figure it out? And number 4 wants you to prove your work, so that would mean that you would just do some skip counting or something like that. So take your time, think about it, and complete page 108. Okay, I hope you had some success with that. I did the problem as well, and I did 7 groups of 5, so you can see my groups. The equal part is the 5 in each group. That's the equal size amount that is in each group. So I have 7 groups, as you can see, and in each group I have 5. So the picture is the repeated addition, or that second factor. So 7 groups, here's my 7. Oops, I want to go back. Oh dear, there we go. My 7 groups, I didn't mean to click, sorry. 7 here, here's my first factor. Second factor is the second factor right here, which stands for the repeated addition, or it matches the picture. So if you look at each picture, you're going to see 5 plus 5, okay, plus 5, plus 5, plus 5, plus 5, and plus 5. So I know that if I skip count by 5 7 times, I'm going to get 35. And here is my solution, or the answer to my problem. Leo used 35 chocolate chips. Here is the whole equation, and I've already talked about that. And to prove my work, I simply skip counted. I skip counted by 5s. So overall, multiplying with 2, 5, and 10 is a fairly simple process, and I think it's pretty easy because you just skip counting by 2s, 5s, and 10s. I think the more difficult part is keeping straight what each factor means and drawing arrays and models to represent that. And the more you do it, the better you'll be. Okay, so you can challenge yourself to make a generalization about multiplying with 0 or 1. Talked about it a teeny tiny bit. I want you to think about that and take the challenge. Try to come up with a generalization. That means like a general rule of what do you do when you're multiplying by 0, or what is the outcome when you're multiplying by 0, and what is the outcome when you're multiplying by 1. And then tell somebody what you're thinking about this generalization. If nobody is nearby, tell your favorite stuffed animal. But take that information and put it in your knowledge bank. And then to recap, I don't know if you can see this, you probably can't. I should have taken a picture of this, and I think it's going to be backwards. But in general, if you have 2 groups of 3, that equals 6. And if you have 3 groups of 2, that equals 6. However, look at my pictures. They look totally different. On this side, on the left, we have 2 groups with 3 in each group. The repeated addition is the second factor. And over here, you have 3 groups with 2 in each group. So see how the pictures are totally different. This one represents 2 plus 2 plus 2. And my arrays are the same way. Here I have 2 rows, and here I have 3 rows. So we took this first one and we really just turned it up for that array. So that's what you really have to know the differences between. So I hope you had fun learning about lesson 5, your first session. And tomorrow I'll work on the lesson 5 session 2. So see you then. Have a good night. Bye-bye. Well, it's a lot of work, but I can't get this to go over. Come on, I need to hit the click button. It's not letting me escape. There we go.